So for this video, I'm going to cover Q20 all the way to Q24. And because I'm running out of space, I need more likes and subscribe so that YouTube allowed me to pack more video on it. So please like and subscribe. Okay, for question 20, it is mainly a moment question. So you are actually told that there is this force acting on the pedal and the pivot is over here. So you're supposed to find the moment. So moment is given by that force times perpendicular distance. This distance is between the line of action of the force. So this dotted line is the line of action of 60 Newton. And the perpendicular distance from the pivot. So from the pivot, just draw a line so that it is 90 degrees to the line of action of the force. So in this case, you will take 60 multiplied by 16. For question 21, it is about stability. So if you look at these bars, most likely it is going to pivot here as it topples towards the left. So if that is the case, if the CG is at A, that means you will draw the weight over here. You can see that when this happens, it will result in a moment that goes this way. And of course, there is nothing, clockwise moment to balance this. So as a result, if your CG is at A, the whole bars will topple. So if you use this logic and you check for B and you check for C, you will see that all three positions will actually cause anti-clockwise moment happening about this pivot over here. And it will cause the bars to tilt and fall. But if you look at D, you can actually see that D is directly above the pivot. So in this case, when you select D, your moment equals to F times D. Yes, you have a force, which is your weight, but unfortunately, your distance over it will be 0 because the line of action is on the pivot. Okay, for question 22, I would say that most of the students are having problem with this. So what happens is that normally when we want to calibrate a temperature scale, what we do is that we find temperature equals to 0. This is what we call the ice point, right? And then we will want to observe that, oh, okay, at ice point, my thermometric property will cause this amount of change, right? And then it can be like the length of a mercury column. And then after that, we put the thermometer at steam point, which is 100 degrees C at atmospheric pressure. And then we observe, oh, okay, my thermometer has made this change. And then after that, what we do is that we assume that what happened between them is linear. And we will then be able to read that, oh, okay, if I got this reaction, it will correspond to this particular temperature. So that is how temperature scale is calibrated. So just one quick look between this and this, you can see that this guy is a curve, meaning that you won't have a pattern like that. So why is this not suitable? That is because if you look at this graph, you can see that every maybe 10 increase, this amount will increase, right? So every 10 degrees Celsius increase, you are going to observe the same amount of change. So in this case, your thermometer will have regular interval because every 10 degrees C change, you are going to get the same amount of observable change. So this thing, in scientific terms, it is called regular temperature intervals. Now let me give you an example on if it is not the same. So we have this, and if now my ice point is here and my steam point is here, but instead of a linear relationship, which means it is a straight line, if now I have a curve, what you get is that this is my temperature, this is my observable change, my thermal property. If I have a 10 degrees C change, you can see that I only have this amount of observable change. Followed by another 10 degrees C change, I will see this much. Followed by another 10 degrees C change, I will see this much. This means that my thermometer scale will look something like that. At first, 10 to 20, I only see this change. 20 to 30, I'm going to see a big change. So you can see that my interval will not be the same. And it is not very easy to read, right? So because of that, if you see that the relationship between your thermometric property and your temperature is a non-linear one, meaning that it is a curve, then you can tell that it is not very suitable because the temperature scale will not be linear, it will not be regular. So let's look at which statement is true. So there are no fixed point. This is not true because you are still relying on the ice point and steam point. So what I have here is that maybe this is the ice point, I observe this, and when it is steam point, I observe that. Then after that, let's say B, thermometric property does not vary linearly. This one most likely is the answer, okay, but we will keep it to the last. Let's look at C. It says that the property decrease with increasing temperature. Now, if that is the case, temperature increase but my property decrease, if it is a straight line, right, it will be fine. Because if it is a straight line, you are still going to get regular change. So your scale will still be regular. So obviously, this is not the reason, right? Because it is not about whether the gradient is negative or whether the gradient is positive. Most importantly is that it must be linear. Okay. Part D, the substance must be in a liquid state. Yes, it has to be in a liquid state. Actually no. Okay, because if it is in a solid state, it can still work because you can measure its expansion. For example, your bimetallic strip, right? It will still work. So out of the 4 options, you can see that actually B will be the best option. Okay, now if you look at your 23, which is not an assumption of your KMM, down here, this one is more on content knowledge. So you need to identify the statement that that is wrong. So gas has far apart molecule, so this one is correct. Gas molecule is always moving and randomly is correct. Gas is made up of large number of tiny particle called molecule. It is correct as well. Pressure of gas is caused by force exerted during collision between molecule. This is wrong. Okay, so pressure is not caused by forces that is exerted on molecules themselves, because pressure is given by F divided by A. This area here, we are talking about the surface area of a cylinder maybe. So we are talking about the force exerted by molecule on the wall of the container. Okay, for question 24, it is tricky in a sense that we have a fixed mass of gas. The piston is frictionless, so it can slide freely. Temperature is gradually lowered. So when temperature is lowered, that means I'm going to lose energy. Which of the following statement is correct? So down here is trapped by an airtight frictionless piston under the action of a constant force. So actually this force is constant, that means it is always being applied onto the piston. So the piston is going to move inward, right, as I reduce the temperature. So when I do that, actually I am reducing the amount of volume inside here. So when volume drop, definitely my pressure will rise. But at the same time, I am losing energy slowly. When I lose energy slowly, right, temperature drops, my pressure will actually drop. So now I am in trouble because one says my pressure drop, one says my pressure rise. So let's take a look. Pressure of the gas decrease, I am not sure, because when the volume drop, I have an increasing effect. When the temperature drop, I have a decreasing effect, so I'm not sure. Volume of the gas drops. This is for sure true because you are pushing the piston inward due to this constant force. Average velocity of the gas molecule drop. This is also true because when you reduce the temperature, you are losing energy, and when a molecule lose energy, it is going to move slower. So I know that 2 and 3 is definitely true, so I will choose C. And thank God the teacher didn't give me an option whereby 1, 2 and 3 is correct. Okay, so if you so if option 1 is also included in the MCQ, please raise your hand and ask the teacher to check whether the question is designed correctly or